Hello everyone. Welcome back to third session of current ongoing series which is statistics and it carries 2 marks. So in today's session we will have a quick walkthrough of topics like skewness and its measurement, kurtosis, its measurement, measure of dispersion, range, interquartile range, mean deviation, variance and standard deviation, coefficient of standard deviation. So before we proceed with this session, I would like to mention that each of these topic is very vast, and if we go very deep into these topics it may take more than 10 or 12 hours. But from IBBA perspective, we need to understand very few basic concepts of these topics, so that in case you get one question out of any of these topics, you can easily score that 1 or 2 mark. So this is the full syllabus of statistics. We have already covered this part in session number 1, and measurement of central tendency has been covered in detail in session number 2. So let us talk first about skewness. Very small things need to be understand from IBBI exam perspective. So from exam perspective, you need to understand these two things. You may get question on this positive skewed and negative skewed. So normal distribution curve, there could be 3 types of distribution curves. Normal distribution curve has normally mean, median and mode, all three equal. We have already discussed mean, mode and median in session number 2 of current playlist. So this mean, mode and median, everything is equal. All three are equal in case of normal distribution. However, if distribution can be skewed in either of the following two ways. So this is right skewed, right? So right skewed or positive skewed, both are similar. Don't get confused with any of these two words. So examiner may give a picture of a curve distribution and may ask you whether it's a right skewed, positive skewed, negative skewed, or normal distribution. So you have to click right answer. So positive skewed or right skewed curve, it indicates a tendency to obtain returns above what is observed in normal distribution. So here mean is more than median and median is greater than mode. This formula also you have to remember, and peak of the curve is mode. Examiner may give a picture of this type and may ask you to calculate mode. So mode is this highest point in all three curves: normal distribution, positive skewed and negative skewed. And this is the pictorial view of negative skewed curve, or also called left skewed. It indicates tendency to obtain returns below what is observed in normal distribution. So here is more area. So left side, it has more area, this picture, and here right side has more area. So that means it has more area under higher return above what is expected under normal distribution. So this area is more than normal distribution area curve for middle point. So measurement of skewness we will discuss in later part of the session for better understanding. These are the two things you should understand about skewness. First has been discussed, and second, measurement we will discuss in later part. Kurtosis. Kurtosis is nothing but degree of flatness or peakedness of the distribution curve. Remember this definition from exam perspective. Kurtosis is a statistical measure that defines how heavily the tails of the distribution differ from the tails of the normal distribution. It can be of 3 types. So normal distribution has specific type of tails, and kurtosis measure deviation of those two tails from tails of a normal distribution. So skewness was about middle point and kurtosis is about two tails, endpoints, starting and end point of normal distribution. From exam perspective, please remember these three terminologies. So kurtosis can be of three types. First type of kurtosis, which is mesokurtic. It is the kurtosis of a normal distribution. If it is a normal distribution, that means mean, mode, and median both are equal at central nodal point, that is normal distribution. Of that distribution, the tails or starting or end point of that normal distribution are called mesokurtic, lipokurtic, or positive or high kurtosis. More values tend toward tails of the distribution curve, that there is a probability of higher extreme values. So area under tail is more than normal distribution, then it is called lipokurtic or positive or high kurtosis. And third, if area under tails is less than the is more flattened and is less than the tails of the normal distribution curve, then it is called platykurtic. So examiner may ask you straightforward definition of these terminologies, or may also give pictorial view of two or three distribution curves, and may ask you that is it a mesokurtic, lipokurtic, or platykurtic. So you should be able to identify which curve is which one. So these are the graphical presentation for better understanding. So if we see, this is the first normal distribution curve. Here tails are this is first tail and this is second tail. So if tails area under tails is more, here you see it is like more like upward, so it is called lipokurtic or positive or high end. So here this is important, this area, right? But if the curve, there are more values towards average of the curve and high probability of getting value near average of the curve, so that means these tails are flattened and their probability of more values are under around this point, that means it is a lower curve. So in this case lipokurtic, we get more value toward tails of the distribution, so it has more area, high probability of getting extreme values here. But here we have high probability of getting values near to average of the curve. So if you remember these two things, that is adequate. So measurement of kurtosis we will again discuss about in towards end of the session for better understanding, along with skewness measurement. Dispersion. So all three curves on right side have same mean, mode, and median, right? So here you see. However, curve A has least spread. So this has least spread under it. And curve C has highest spread. So this covers maximum area. This you see. This degree of spread or variability is required to be measured to compare these three distributions. The measure of spread or variability is called dispersion. So first we discuss about the nodal point. Compare distribution curve with respect to the nodal points. And second we discuss about their tails. Now we are talking about if their mean, mode, and median are same or all are normal distribution, then even then we want to cover or measure the area under each curve, then dispersion is a measure of that spread or variability under a curve. This is dispersion. Just remember this definition. The measure of spread or variability is dispersion. Measure of dispersion, they are following 5 types of measures of dispersion: range, interquartile range, mean deviation, variance and standard deviation, coefficient of standard deviation. So you may get question on any of these formulas as well. Let us first talk about range. Range is the difference between the highest and lowest observed value. Range cannot be computed in case of open-ended distributions. So let us understand range with the help of an example. So if we have this data and examiner asks us to calculate range of this data, in that case, so we have to identify the lowest number in this data, which is 75 here, and the highest number in this data, which is 175. So highest observed value is 175, lowest observed value is 75. So that means range is nothing but equal to highest value minus lowest value. Interquartile range. Interquartile range claims itself to be better measure of dispersion. Why? Because it says that this range shaves off lower observations 25% and upper highest observations, because these are tail data and they are not giving real picture of the data. That's why we take out 25% lower data, 25% upper data. So this is calculated basis middle 50% data. So range is based on two extreme items and fails to take into account of scattered data within the range. To address the challenge, interquartile range measures range of middle 50% of distribution, this area. 25% here, 25% here, 50%. So because it excludes 25% lower data and 25% upper data. So formula for interquartile range is third quartile minus first quartile, Q3 minus Q1. Third measure of dispersion is mean deviation. Mean deviation is also called average deviation. Just remember formulas for this. It is the average difference between the items in a distribution and the median or mean of that data. Mean deviation is also called average deviation. So these are the two formulas for calculation of mean deviation or average deviation. In case of ungrouped data, mean deviation MD is equal to this formula. Just remember it. You have to remember this formula, right? And for average deviation, this is the second formula. Just remember it. There is no derivation, and let us not discuss about the derivation of this formula. Just remember it. You may, very less probability you will get a question on it, but still it may come. So coefficient of mean deviation is equal to mean deviation divided by mean. Sometimes examiner asks this thing. It may give you mean deviation and mean and may ask you to calculate coefficient of mean deviation. Let us understand this concept with the help of an example for better understanding. Let us examiner gives us this data and asks us to calculate mean deviation and also coefficient of mean deviation with this data. So here sale price has been given, range and number of transactions of the property. So this is given in the question, like sale price of the property and number of transactions happening in that price range. So 25 data pertaining to 25 transactions has been given by the examiner. So midpoint of each class, which is this 7.5 plus 12.5 is equal to 20 divided by 2. So 10, 15, 20. You can see here 25, 25 here, 30, 30. So this is the middle point. First you have to calculate this one. This is xi and number of transaction is frequency fi. So we have to multiply xi fi. So x1 f1 20, x1 x2 f2 60, x3 f3 120, x4 f4 200, x5 f5 150. So sum total of xi fi is 550. right? And then average of this XI-FI is 550 divided by 25. It is 22. Calculated here. Then DI is equal to XI minus X average. So deviation. This figure we have to calculate. And 22 minus 10, 12. 22 minus 15, 7. 22 minus 20, 2. 25 minus 22, 3. 30 minus 22, 8. So there is a asterisk here. Please note that since it is under 2 bars, while calculating D, only difference is important. So it can never be negative. It always has to be positive. This DI value has to be positive because we are measuring the difference, not the direction. Then we have to calculate DI multiplied by FI. So DI is 12 multiplied by 2 is 24. Likewise this. Calculate all and take sum total of DIFI 128. Now we remember the formula. Mean or average deviation formula is this value divided by sum total of frequency. Total frequency 128 by 25, 5.12. That's answer number 1. And coefficient of mean deviation is MD divided by mean. So here it is MD 5.2, 5.12, and mean is 22. So 0.2327. That's second answer. Calculate mean deviation from median and also coefficient of mean deviation of the following data. So in the second example, we calculated mean deviation with the help of mean. Now we are calculating mean deviation with the help of median for same data. Let us see. So this is the same price category, same number of transactions. So we calculate midpoint of each class like in previous case. Then we have to calculate frequency, cumulative frequency to calculate median. If you do not know how to calculate median, please go to session number 2 of this playlist. Then 6 comes from 2 plus 4. 6 plus 6, 12. 12 plus 8, 20. And 20 plus 5, 25. And this is the capital N. Again, difference between XI minus median. So 12.8. So this 10 is, these figures are coming from here. And 22.8 is coming from here. This is the formula. Please refer to session number 2 of this statistic playlist. We have already learned how to calculate median of data. So here N is 25, N by 2 is 12.5. Middle class of interval is this one. So this is the middle class. The lower limit of the middle class is 22.50. This is the 22.50. Cumulative frequency of previous class, which is this one. Frequency of middle class interval, this is this 8. Class width of middle class interval, which is 27.5 minus 22.5 is 5. So this is the formula which we have learnt in session number 2. If we enter all these details into the formula, then this median will come. First we have to calculate median. So DI from, subtract XI from median and take positive value of all differences. These are the differences. Then we have to multiply this difference with individual frequency of each class. So 12.8 multiplied by 2 is 25.6. 7.8 multiplied by 4 is 31.2. Likewise, all these figures will come, and then we have to calculate sum total of this value DIFI. So that means we know the formula. Mean or average deviation is sum total of difference and frequency divided by sum total of frequency. So 128 divided by 25, 5.12, same value. And coefficient of mean deviation divided by mean 22. So we had calculated mean from the example 2. 5.12 divided by 22 is 0.2327. It's similar. Next is variance and standard deviation. Variance is the mean of squared deviation from the arithmetic mean. And standard deviation is a square root of the variance. Standard deviation is the most important and widely used measure of studying dispersion because it is free from most defects from which the earlier methods suffer and satisfies most of the properties of a good measure of dispersion. The standard deviation measures the absolute dispersion or variability of the distribution. A small distribution means higher degree of uniformity of the observations, that is homogeneity. A large standard deviation means the data is heterogeneous. Please remember all these points from exam perspective. Examiner may ask any theoretical question out of any of these lines. Don't go deep into these, just overview, and the information I'm sharing in this presentation is more than enough for scoring marks in statistics because it is itself a very, very, very lengthy topic. Don't waste your time on it. Then mean deviation versus standard deviation. What is the difference? So both are measure of dispersion, but they are different in following two ways. Algebraic signs are ignored while calculating mean deviation, whereas in case of standard deviation, algebraic signs are taken into account. However, the signs becomes redundant while calculating SD, standard deviation. Mean deviation can be calculated either from mean or median. However, standard deviation is calculated using arithmetic mean. This is the second difference between MD, mean deviation, and standard deviation. Simple variance and standard deviation. If population size is very large, then calculating measure of central tendency and dispersion is quite time consuming. In some cases, data for entire population may also not be available. In such cases, a sample is taken out and measures are calculated for the sample. So these are the formulas for population variance for a large data, say more than 30. You have to remember these two formulas. Population variance formula is this. First formula or second, whichever is easy for you to remember, and this second for group data. And population, once you calculate population variance, then population standard deviation is equal to square root of variance, this value. And in both cases, for group data and ungroup data. If sample size is small, say less than 30, then the formula will be little bit different. This is the formula for that. Just remember, note down of these formulas and have good memory in your mind. Now, use of standard deviation. These three bullet points are also important. You may get a direct theory question from this slide. So in case of normal distribution, approximately 68% of data falls within one standard deviation from mean. 95% data falls within two standard deviation of the mean. 99% of the data falls within three standard deviation of the mean. Standard score, it tells the number of standard deviation a particular observation lies below or above the mean. The examiner may ask you to calculate standard score, population standard score, then you have to use this formula. Observation whose standard score is to be calculated, that observation value, and x minus mean. So it's distance from the mean. This is the distance divided by population standard deviation. That is standard score of a particular value in a population data. Coefficient of standard deviation. Standard deviation cannot be a sole basis for comparing two distributions. One distribution may have standard deviation of 10 and mean of x, mean of 5. However, another standard deviation may have standard deviation of 10 and mean of 5000. Thus, we cannot know the dispersion of data set until we know standard deviation and mean both. So they both are important. Only standard deviation cannot give actual measurement of dispersion of data. So coefficient of variance or coefficient of standard deviation is one such tool which measures dispersion by expressing standard deviation as a percentage of mean. And the formula for population coefficient of variation or standard deviation is equal to this. Let us understand with the help of an example. In a quality control, a laboratory technician A completes on an average 40 analyses per day with standard deviation of 5. However, technician B completes on an average 160 analyses with a standard deviation of 15. Which employee shows less variability? So coefficient of variability can be measured with the help of coefficient of variance. So here we have been given standard deviation and mean. Both figures are given in the question. So for technician A, standard deviation is 5 and mean is 40. So 5 divided by 40 multiply by 100 is equal to 12.5%. So this is the coefficient of variance for technician A. However, for technician B, standard deviation is high. But if you compare with average of 160, so average or coefficient of variance for technician B is 9.5, 9.4. So standard deviation for technician B was high, but coefficient of variance is low. So technician B shows less variability. Sachin Tendulkar scored 10,000 test runs with an average of 54 and standard deviation of 9. Whereas Brian Lara has scored 8,000 test runs with average of 60 and standard deviation of 18. Who is the most reliable player among two? This is a real example from IBBI exam. This question has come in the exam. So similar type of question may again come. So again, to ensure reliability, the player who has less variance for more reliable scores is more reliable player. So we have to calculate coefficient of variance for each of the player. So standard deviation is given for Sachin Tendulkar is 9. However, average score for Sachin Tendulkar is 54. So coefficient of variance for Sachin Tendulkar is 16.66. However, for Brian Lara, standard deviation is 18 with average score of 60. So here it is 30. So that means Sachin Tendulkar is more reliable player than Brian Lara. Now we have to discuss about measurement of skewness. Measurement of skewness, dispersion tells about the amount of variance instead of its direction. So dispersion tells the amount but not the direction. However, skewness tells about the direction of the variance or departure from symmetry. In fact, measure of skewness is dependent on the amount of dispersion. Skewness can be calculated either as absolute or relative as under using mean, using quartile, using statistical movement. Let us first see how we can calculate skewness with the help of using mean. So this is the formula. Absolute skewness is equal to mean minus mode. More than if it is greater than 0, like positive, then it is called positive skewness, which we discussed in initial slides of the presentation. And if it is value is negative, then it is called negative skewness. Greater the skewness, more asymmetrical the distribution. Remember this line as well. Using quartile, absolute skewness is third quartile plus first quartile minus twice of the median. This is the formula. And statistical movement, skewness is M3M divided by standard deviation raised to power 3, whereas this is standard deviation. M3M is third moment about mean and can be calculated for ungrouped data having mean as under. So it's very rare you will get question on this formula, but have a basic idea of this measurement of skewness. Normally you will not get question on these calculation, but a basic theoretical question around understanding of the concepts may come. It's very rare, but still it is part of syllabus. That's why it has been covered here. So M3M is calculated using this formula if it is a large data, and if it is small data, then use this formula. Okay, Kurtosis measurement. So using statistical movement, this is the kurtosis. Skewness is M4M divided by standard deviation raised to power 4, whereas formula for M4M is this for large data and for small data. So this is also important. This summary is important actually from exam perspective. Right? So you may not get this information anywhere, but that's why it is called bonus content. So kth movement from origin is defined as mk0. So we talk about third movement, fourth movement in previous 2 slides. So if you want to calculate any movement, so this is the formula. This and this. So first movement around origin is mean. So this is important. So if examiner is asking you what is the first movement of this distribution come, you have to calculate mean in that case, right? And if examiner is asking for second movement around mean, that is variance. Calculate variance of the data. So indirectly examiner may ask you to calculate second movement around variance, around mean. So that means examiner is asking you to calculate variance. And if it is asking for third movement around mean, it is skewness, this one. And fourth, this one. So remember these four formulas, it will be easier for you. Thank you very much for watching third session of the current playlist. Before I tell you what we are going to cover in fourth session, I would again request you to please subscribe to the channel if you have not done till now. Click on bell icon so that you will be notified about upcoming sessions, and do like and share this video with your near and dear one so that they can also get benefited with this channel. So upcoming session we are going to cover remaining these topics, and only 2 sessions are pending. Elementary theory of probability and probability distribution, sampling and sampling distribution. Simple test of significance, regression, correlation, multiple correlation, coefficient, time series and index numbers. So sometimes question may do come out of any of these topics as well. Thank you.